Hello, and welcome to this presentation, Understanding DMMs Temperature Measurements. In this short presentation, we'll explain the basic principles and procedures used in measuring temperature with digital multimeters. There are many different instruments and devices that can measure temperature, and this includes some digital multimeters or DMMs. In order to measure temperature using a DMM, a special temperature sensor or probe must be attached to the meter. The meter measures some temperature-dependent quantity, normally a voltage or a resistance, and then converts this quantity into a temperature and displays the result. Different types of sensors are used depending on the measurement requirements, such as accuracy, speed, temperature range, etc. The two main types of temperature sensors used with digital multimeters are thermocouples and resistance temperature detectors, or RTDs. In the remainder of this presentation, we'll take a closer look at each of these sensor types. Thermocouples are formed by joining two different or dissimilar metals at a junction. In temperature sensors, this is often implemented using two wires made from two different metals. When the junction is heated, a voltage is produced between the two wires. For thermocouples used with multimeters, this voltage is typically on the order of millivolts, and increases with increasing temperature. The DMM senses or measures the voltage and converts this to a temperature. Thermocouple sensors are very common, and they're most frequently used with handheld digital multimeters. The attachment to the meter is made using a single pair of leads. Thermocouples are made in 8 standard types, each of which has a characteristic voltage versus temperature curve. These types are designated by letters, such as E-type, J-type, K-type, R-type, etc. Each type uses a different combination of metals, and therefore they have different characteristic curves. Note that some types, such as R, are better suited for higher temperatures, and others are better for lower temperatures. K-type thermocouples are the most common type used with DMMs. They have a reasonably linear response over a wide temperature range, and because they are nickel-based, they have good resistance to oxidation and corrosion. The other common type of sensor is a resistance temperature detector, or RTD. As the name implies, the resistance of an RTD is measured and then used to calculate temperature. The resistive element is usually either a wound metal wire or a thin metal film, and these are normally contained within a sealed probe. The resistance of an RTD increases with increasing temperature. That is, it has a positive temperature coefficient. Similar to thermocouples, there are different types or varieties of RTDs, each of which have different resistance versus temperature characteristics. RTD sensors are more often used with benchtop rather than with handheld DMMs, and the conversion of measured ohms to temperature is handled automatically by the meter based on the selected RTD type. RTD sensing elements are usually made of an alloy of platinum, nickel, or copper. Although it's higher cost, platinum is the most common or preferred metal for RTD elements. First and most importantly, platinum has a much more linear resistance versus temperature curve than either nickel or copper. Platinum can also handle much higher temperatures and is relatively inert. That is, it does not react much with other elements or compounds. Because the atomic symbol for platinum is Pt, RTD temperature sensors made from platinum alloys are prefixed with those letters. The number following the Pt designation is the resistance at 0 degrees Celsius. A PT100 sensor has a resistance of 100 ohms at 0 degrees Celsius, as shown here. A PT1000 sensor would have a resistance of 1000 ohms at 0 degrees Celsius. Recall that for all RTD types, resistance increases with increasing temperature. The rate at which the temperature rises is a function of the purity of the platinum alloy. This is quantified as the alpha coefficient. The most common alpha coefficient for PT100 sensors is 0.385 ohms per degree Celsius. The alpha coefficient is often suffixed onto the end of the probe type designation, as shown here. Using the alpha coefficient and sensor type, it's very easy to calculate temperature from resistance. But since this curve is not perfectly linear, higher accuracy can be obtained by using a lookup table for the particular sensor type being used. Only 2 wires are needed to measure resistance, so basic RTD probes will connect to a DMM using only 2 wires. However, the resistance of the leads themselves will be added to the sensor's resistance, and this will impact measurement results. More specifically, the added resistance will cause the calculated temperature to be skewed slightly higher. This situation can be improved by using 3 and 4 wire connections, since these allow some or all of the lead resistance to be removed from the measurement. 3 wire connections are the industry standard, and most commonly available RTDs come with 3 wires. Using 3 wires provides a good compromise between cost and accuracy. A 4-wire connection is most often used in laboratory applications, and although they're higher cost, they provide the highest accuracy. Most benchtop multimeters support both 2 and 4-wire connections, with 3-wire sensors being connected using only 2 of the supplied wires. Now let's compare the properties of thermocouples and RTDs. Thermocouples have a higher maximum measurable temperature and a faster response time. Response time refers to the time needed to register a temperature change. RTDs, on the other hand, tend to have better accuracy, and this is due in part to the higher linearity, sensitivity, and stability of RTDs compared to thermocouples. All of this does, however, come at a higher cost, with RTDs typically being several times more expensive than a similar thermocouple. So in general, thermocouples are best when measuring high temperatures or when speed is important, and RTDs provide higher accuracy but are more expensive. Let's end with a brief summary. Measuring temperature with a DMM requires a temperature sensor, of which there are 2 main types. The first is thermocouples, with K-type being the most common type used with DMMs. These thermocouples use a junction of dissimilar metals to create a voltage that varies with temperature. Thermocouples are the most common type of temperature sensor used with handheld DMMs. The second type is resistance temperature detectors, or RTDs. These sensors, usually constructed from a platinum alloy, contain a resistance that increases with increasing temperature. RTDs are more commonly used with benchtop DMMs, and may have 2, 3, or 4 wires for connecting to the meter. Although both of these types of sensors can be used to measure temperature, it's important to ensure that the selected DMM supports both a given sensor type, and that the sensor type or parameters are correctly chosen and configured. This concludes our presentation, Understanding DMMs, Temperature Measurements. If you'd like to learn more about other types of multimeter measurements, or about multimeters from Rohde & Schwarz, please see the links in the video description. Thanks for watching.